Hey students, Mr. Halpern here. So the last video we're going to be doing is molecular formulas. And really this is just, taking what you have done with empirical formulas and adding one more step to bump it up to the regular or normal formula for the actual molecule you're looking at. All right. And in order to do this, I want to just give you really quickly, an example problem. So, I could really give you, you know, any sort of problem to do. If I go randomly to a problem here, you know, I could find all sorts of things like, um, oh, I don't know. There are a bunch of different questions here, but, you know, one of the things that you want to be able to do is know first what is the molecular formula um, versus an empirical formula, right? So, um, okay, so this is a good one here. We can do that one. That would be good. Okay, so I'm going to go ahead and take this one. This is a good one here. Okay, so as I've said in the previous videos, um, for the most part, you're not given anything on this test except for periodic table and some of like the obscure, factor label things, conversion factors. But so this formula here, it kind of, goes into that. You're not given this particular formula. You need to know what to do to get there, and this is what you do. So, so the first thing you have to do is figure out what the empirical formula is by percentages in this case, and then you figure out what the molecular formula is. Okay? So let's take a look. So the first thing is you want to go for the empirical formula. You're going to write down lithium, Li, and that's 18.7%. So I'm going to immediately convert that into grams. And then for carbon, it's 16.3%, so 16.3 grams. And for oxygen, 65%, so it's 65.0 grams. I'm going to divide by lithium's molar mass. So lithium's molar mass is 6.94. Now I'm going to divide by carbon's molar mass, 12.01, and then lastly oxygen's, which is 16. And I get 18.7 divided by 6.94. We have 2.69. Next, we have carbon. Carbon is 16.3 divided by 12.01. One 1.36. And lastly, 65 divided by 16, 4.06. Looking at this, the smallest number is 1.36, so divide by that. And what we get is roughly 2, 1, and in this case it would be 3. Okay. Again, you can do it in your calculator, but that's what you get. So the empirical formula is Li2 CO3. Okay. All right. So now what we do is we have to figure out the molecular formula. To do that, we need to use this calculation above. So we have the molecular formula molar mass, which is here, right? the molar mass of the compound is 63 grams per mole. That's what the molar mass is for the molecular formula. Okay, so if you have the empirical formula, then you can figure out the empirical formula molar mass. So the empirical formula is this. So the molar mass of this would be two of those. So two lithiums would be 6.94 6.94 times 2 plus carbon, which is 12.01. There's just one of them. So plus 16 times 3. And together that equals 48, 73.89. That's the empirical formula molar mass, right? That's the molar mass of this. So that goes here, okay? So I have 73 and 73.89. So this roughly equals 1. What does that mean? That means that the ratio of the molecular formula to the empirical formula is 1. In other words, the molecular formula and the empirical formula are the same. Now, if I, for whatever reason, was told that instead of this being 73 grams per mole, the molecular formula molar mass was, say, 146. Well, 146, if I write that here, right, divided by 73.89 would be 2. What would we do then? Well, I would take my empirical formula and I'd multiply each of the subscripts by 2. So Li4 C2O6. And that would be my molecular formula. So you're going to take your molecular formula, molar mass or weight, and you're going to divide it by the empirical molar mass, which is what you do by adding the molar masses of the elements up for the empirical formula. And that was 73.89 in this example. Okay, now there are a couple of curveballs. You might be, you might get to the molar or empirical formula, and then they give you a number of atoms and a number of grams, and you have to figure out the molar mass given those two pieces of information, or you're given a density. There are different ways in which you can basically add in a mole problem just to get to the molar mass, and then and then use that for figuring out the molecular formula. If you want, we can do some of those in class or one-on-one. Hopefully this was helpful.